Hello again. Today we're going to look at RIP. The first packet tracer I'm going to do is RIP version 1, and then I'll do RIP version 2. The main differences between the two is RIP version 1 is generally used for classful networks. You can jag it with classless networks, but you're far better off with version 2 for classless. The reason being that when RIP version 1 sends updates from router to router, it does not send the subnet mask. If you get rid of some bits in there, we'll go through those. Version 2 will send the subnet mask with the update. So when we're playing with CIDR and VLSM, so CIDR, CIDR is classless interdomain routing, and VLSM is variable length subnet masks. They're kind of interchangeable in a way. Then version 2 is what you'll use. But in our network, what we've got here is actually everything is classful, which means that every network that I have defined internally, not this interweb thing, but internally is a classful address. So this is a 192.168.111 with 24 bits in the subnet mask, so that's a C class address. Down here we've got 192.168.10 with 24 bits in the subnet mask, so another C class. Down the bottom right here in the orange, 172.20.00/16, so 16 bits in the subnet mask. There's a B class, so very classful. And then the three WAN connections, 10.0.0.0.8, 11 with 8 bits in the subnet mask, and 12 with 8 bits in the subnet mask, all A class address spaces. So we've made them classful because that's version 1 really. The LAN, so the purple, orange and yellowy colors are all non-routable network addresses. The 10 is non-routable, but the 11 and 12 are routable across the internet, so be careful of using those on an internal network. But we're just using here just to get the feel for it. Okay, so we'll go through why we're going to use RIP quickly, and work our way from there, and then we'll end up with a nice network all built and everyone will be able to ping each other. So let's just have a look at router 1 down here, and there it is. If we show IP route, I have 3 directly connected networks, so as you remember from static routes and other bits that we've done. So this is 10.0.0.8, so serial 000s on that network. The 12 network is through serial 0.0.1, and then through our gigabit Ethernet 0.0 we've got our 192.168.10 network. But there's no other networks defined in there, so no statics are on this network. No other routes to get anywhere. So if I wanted to ping 192.168.111 from this router, or from this PC down here, and it'll get to this router, then this router will look at this routing table and go, well, there's no path to that network up there, the little purple network, therefore I will dump the packet and send back a thing saying unreachable. So we need to set up and get everything up and running so that we can ping that network up there, because that's what we want. We want connectivity. Now, before we start chucking in routing protocols, what we should really test is that router 1 can actually ping router 2, and router 1 can ping router 3, and then same for router 2 and 3. Now, I've done this before, but let's just go through the process. We should make sure that all our interfaces are up and running, that we've got this routing table sitting there. Router 2 and router 3 have the correct routing tables. Once we've got that up and running, then let's put our routing protocol in. Otherwise you're just asking for trouble. So let's just ping stuff. So I'm going to ping 12.0.0.1. I know it's the other end because my end is 12.0.0.2, so I've got success there. So I've pinged router 2 because my network diagram shows that that is the network and it's correct. So let's ping 10.0.0.2 now. So Oops. Just hit the up arrow there just to come back to the previous command, modify it, and to ping 10.0.0.2 is on router 3. And I did test these before, so everything's good, everything's connected, configured correctly. Now let's move on from there. Okay, so on router 1, what we're going to do is put in our commands for RIP. Routing IP pretty much is the protocol. It's a pretty clunky, horrible protocol, but it's there, so we now need to know how to use it. So for very small networks, fine. For bigger networks, get something better like OSPF or EIGRP. Okay, so let's get into it. So configure terminal, and in our config mode we go router RIP. Now if we just put in router and put a question mark, then in packet trace we've got these options. Now on physical devices you'll actually have more options, but we've got border gateway, which is what your internet service provider will use. That's an external routing protocol. These three are the ones that we use for CCNA. Excuse me. They're internal gateway or internal routing protocols. So EIGRP, created by Cisco. They've released most of it, but not all of it, to open source. OSPF is open source, so open shortest path first. A slightly different protocol to EIGRP and RIP, in that RIP and EIGRP are distance vector routing protocols, and OSPF is a link state routing protocol. So when we look at RIP, we'll get a cost to get to a network, and we'll also get the vector, which is the exit interface, where OSPF will be done differently. But anyway, we digress a wee bit there. So let's go in. Our command router RIP says let's configure RIP on this router. You can configure all these protocols on this router actually, and they can all run together. Not too sure why you do it, but it can be done. Okay, so we're in router RIP. Put a question mark in there and see what options are there for us. We've got auto summary, default information, distance, passive interface, redistribute, and other things in there. The ones we actually want to play with to start with is network. So network as a command says these are the networks that we want to advertise off this router, and the only networks that we can advertise are those that are actually connected and up. So these three networks, 12, 10 and 192.168.10.0, are connected and up. If we scroll up here, we look at our routing table. Again, it says these are the directly connected networks, 10, 12, and 192.168.10. So those are the only ones we can advertise on this router. We will not advertise, say, this orange network down here, 172.20, because it's not physically connected to this router. So only ever advertise the network number that exists on that router. So network 10.0.0.0 exists, so we chuck that in. I'll hit the up arrow, and the other network that is A class is the 12 network, so we'll advertise that one. And the other network that we're doing is 192.168.10.0, so this network here, and we will advertise that. So you can use short again. Now what's that done for us? We have sent out, or this router should be now sending little RIP updates every 30 or 40 seconds. Always forget those. So let's just go into simulation mode, and we'll just auto capture for a bit. So Cisco Discovery Protocol is running somewhere, so we'll just keep having a look. So eventually this router should run RIP, and it should broadcast it out of these interfaces, because it is, there it goes, RIP version 1, and it's just sent it out to the devices. Now it's sent it down here, and it's also centered up there because those are the networks that we've actually added to our device. So nice to know that we're sending updates to this router up here, sending updates to this router up here. We don't actually want to send them down here, and later on we'll stop that, but there's RIP going again, sends it out. What it's sending is saying, in my routing table in RIP, let's just turn that off, I have a certain bit of information. Let's go into that again. So show IP RIP, and put that in there, and pretty much the database, show IP RIP database, is saying this network is directly connected, that network is directly connected, and that network is directly connected. I will send those networks in a packet off to these guys up here, and we can actually see that as well. If we type in debug IP RIP, so debug IP RIP, we've turned on debugging for RIP, and it'll give us information. So when it decides to send it off, off it goes. So let's just undebug all. That says turn all debugging off, and let's have a look at what actually was sent. So RIP sent updates. Let's have a look up there. That's a nice one to get. So it sent a version 1 update to this broadcast address, so again fairly clunky, out of serial 001. So it sent it up this path, which is 12.002 IP address, and it sent this information. It said, I know where the network 10.000 is, and it's one hop away from you. So router 2, to get to 10.000, it's one hop away from me. Also, the network 192.168.10.0 also is one hop away, one router's hop, and that's true. So for router 2 to get to the 10 network, it's got to go through this router 1, and for router 2 to get to the 192.168.10 network, it has to go through router 1 as well, one hop away. You'll notice that it does not send the 12 network as part of this information, because it knows at the other end of this there is the 12 network there. So this router should know where the 12 network is. So it only needs to send a certain bit of information. So that's good. We've actually configured really basic RIP version 1. So if we show our running config, and we'll scroll right down, all the way down, all we've done is put in router RIP, and we've put in these classful network numbers, and they'll always come up as classful even if you're using version 2 actually, and we'll see that later, but that's all we've put in. So we need to put onto each of our routers this similar information. So whichever networks are connected to router 2 and router 3 that we want advertised, then we need to put this information in there. So let's do that. We'll do it on router 2. So Cisco enable class, configure terminal, conft for short. So again, the commands, router RIP and network 12.0.0.0. So we're on router 2 up here. 12 is connected down here, so I'm going to put that in there. I'm going to also connect network 11.0.0.0 because that's the network down this path. And I'm also going to advertise, this C-class network, which is 192.168.111.0. So far so good. Let's have a look at our show running config. That's it, nice and short, show run. And we'll spacebar all the way to the bottom. So there's my router RIP. These 3 networks exist on this router. 192.168.111, so that's C class. 11 is the A class on this side, and 12. So these are the 3 directly connected I want advertised. There's this interweb thing out there. I don't want to advertise that network because I'm going to be sending RIP updates out there, and I don't want that. So good. So what's the net effect of that? So let's go back to router 1 and we'll show our IP route. So look at our routing table on router 1, and it's grown. We now have an entry with a little R at the front of it, and that R says that we're running RIP. We've actually got 2 entries with R in front of it, which is actually what we want. So let's look at the first one. It says in this line that this route, on this route down here, has come in via RIP. It's learnt via RIP, and it's for the 11 network with 8 bits in the subnet mask. So we're matching the first 8 bits. So anything that starts with 11 in the first octet has a path. It's got this, which I'll come back to, and we can find it out of serial 001. So this network here, I got that wrong, didn't I? 11 network down here. This network here has been found going via serial 001 up this path down to there. We haven't configured 3 yet, so hold tight, because it will change a wee bit. But let's just have a look at this line. So it's going to be found via 12.001, which is fine, which is the next hop address up there. This little bit in here is a bit of interest as well. The 1 says how many hops does it take to get to this network, and it takes 1 hop to get to this network from this router, and it uses these as its metric, and its metric is the cost. So if there's 5 costs to get to this network number via another path that we don't have yet, then this is the best path because it's only 1 hop, therefore it's going to be that path there. So the hop count is the best path to this network. This 120 here is the administrative distance. So the admin distance is the router telling itself of how trustworthy this path is. Now, directly connected have an admin distance of 0, so they're the most trustworthy because they're fully directly connected to us. Static has an admin distance of 1 unless you change it as a backup path, which means it's more trustworthy than that path there. So if we were to have a static route of 11.000 with 8 bits in the subnet mask, then this route will not appear in our routing table because the static one is more trustworthy. So play with that and see how it goes. So RIP is actually 120, ERGRP sitting at 90, and OSPF at 110. So yep, information is given to us from the other routers to find different paths to different networks. So when we play with routing protocols, make sure you have a look at this routing table, make sure that what is in there is actually what you expect, and everything is good with the world. So it's an interesting one actually, because we should be able to start pinging things. I should be able to ping this address here from this router or from this PC down here. But let's go through and converge the whole lot rather than have errors in there. We need to get router 3 up and running. So let's get router 3 up and running. So Cisco enable class is the password for enable. So configure terminal, and we'll screenshot over a wee bit. So we want to run RIP off this router. So router RIP, get that out the way. And networks that I'm going to advertise are the 11.0.0.0 because it's directly connected to router 3. The other network down the bottom is the 10 network there. That's directly connected to router 3, so we'll advertise that. And I need to advertise 172.20.00/16. So network 172.20.0.0, and that gets chucked in there as well. So Control Z to get back to router 3. When we put these in, we're actually triggering events. RIP should send updates straight off and not wait for its cycle to go through. So as soon as we chuck it in, it should trigger an event and it should go across these networks. But in our case, let's just fast forward time a wee bit just to have a look at what's happening in there. So let's have a look at router 1 again, because that's what we were looking at before. And we'll show IP route now. And it has changed. So this is what we had before, and this is what we've got now. So we've acquired the 172.20 network as a new line, but we've also acquired something else. You can see now that to get to this 11 network from router 1, it says there are now 2 paths available to us. One is via 12.0.0.1 and the other one is via 10.0.0.2. The reason for that, it's actually doing a load balance. So when we ping from router 1 to 11 network, it doesn't matter which end of it, it's just getting to that network. This router says, well, I've got an equal cost. I've got a cost of 1 via this serial interface, and I've actually got a cost of 1 via this serial interface. So I'm going to load balance. I'm going to send 1 packet down this path and 1 packet up that path. And we can see that actually working. Just go into simulation mode, and we're going to ping from this PC. So let's ping 11.0.0.1 and hit enter. Oh, it's going to run ARP as well. That's terrible, isn't it? Oh well. Let's hit capture forward quickly. So ARP we should be comfortable with. Okay, so there's our ICMP. I've just hit too many capture forwards there. It's sitting on a router. It's going to choose 1 path to go. So let's see. Goes up that one to router 2 this time, and goes down to router 3 because that's where the actual IP is. And router 3 is actually sending it back this way because its routing table, show IP route, says that this packet destination, let's have a look at the destination, so outbound PDU, the destination IP is 192.168.10.2. so let's have a look at the routing table. So 192.168.10.2 is the destination IP address. The closest match we can get is the first 24 bits. So remember that the routing table is only looking for as many matches as it can. So the closest matches it can get is 192.168.10, and that's to go via this path, which is actually down this way, down that 10 network. So that ping has gone all the way around. It doesn't have to come back the same path. Let's come back to there. So let's keep capturing forward, and that'll go back to our PC. And it'll send another ping now. And what we were actually looking for is the load balancing, and there it's gone. Before we went up to router 2 and down, this time it said the same destination. So the destination hasn't changed. So destination is still 11.0.0.1. And now it's gone down this path and back, and all good. So there's a few things in there, and now this one will go up the top and down. So it's working really nicely, isn't it? It's going quite quick, isn't it? We should slow it down a bit. But all well and good. This one will go down the bottom and nice and slow. Tuk, tuk, tuk. Little tractor. So there's a few things in that. Now RIP's going to update. Nice chatty network. We're still sending stuff down here. We don't really want that. And RIP2, you notice it didn't go out there. We're not advertising out there. That's nice. And that guy's there. So they're all run at their own pace. We'll hop out of that. So there's a little bit in that we've actually done. That's basically all we need to do is to set up RIP is run our basic command, so router RIP in config mode, and then advertise the networks are directly connected. When router 2 receives an update, it builds a routing table based on what router 1 has sent and based on what router 3 has sent, and it will work out the least cost path to a particular network. Where the costs are equal, it will load balance. We'll see that. And interesting enough, where the cost is higher, it will not load balance. It will choose the lowest cost path. So let's just show IP RIP database again. And in here, we should see that the cost to get to 172.16, it doesn't really show it actually, it's just chopped it out. It does show it's only a cost of 1, that there, which is actually this path across there. But there is another path to get to the 172.20 network. It's up this way. So there's a backup path that we've got now. We've actually got a redundant link sitting in there. So it will sit there, and let's just have a look at it. Let's just kill that link at the moment. And we need to fast forward time because RIP is a very slow converging network, which means it'll take a while for router 1 to actually work out the best path to this network. So show IP route, and there it is now. We still have the 172.20 network, so we're on router 1 over the left hand. We're trying to get to this orange network which is hiding around the corner. And to get there now, we have said we're going to go via serial 001, which is this interface there. And we're still using RIP, so it's got our administrative distance of 120. But now we have 2 hops in the metric option. And 1 hop is router 2, 2 hops is router 3 to get to this network. So that's the cost of that path there. So our backup link has died, and now we've got 2 hops in there. So far so good. So let me just chuck in our cable back in there quickly, and it'll all reconverge, so we'll fast forward time again. Now there's a couple of other things we actually want to add to this network to make it a bit cleaner. Now, when we had RIP running, let's go back to simulation mode, and oh, there's RIP running now, actually. Perfect. We'll capture forward. We see where it runs to. So RIP is coming down to router 1, down to router 3, which is where we want it, and it's going down to this network down here as well. I don't actually want it coming down into here. Same with on router 1. I don't want this RIP update going to my PC or my server. Router 3 will kick off in a minute. We'll notice again that it's not going out to our internet because I have not advertised this network in RIP, which I don't want to do. So how do we get rid of the option for RIP going down these paths? So let's go on to router 1. Now, the interface that this network is on, 192.168.10, is on gigabit 00. The other way to find it is to show IP interface brief. It's a shortened version, isn't it? And we'll see that it's on gigabit 00. So I want to put a command into my router RIP option. So configure terminal, and I'm going to go into router RIP, and let me put my question mark in there. Let's move this right over. That's the option there. It's actually passive interface. So passive interface is gigabit 00. And that says do not send routing updates out this direction. I have seen it in the past where we actually had a router down in this path, and actually router 1 did build it, but it's worthwhile playing with it because this should suppress all routing updates on that interface. So it won't send updates out onto my LAN. So passive interface gigabit 00. Now be careful of this, because if you put in serial 000, which I'm not going to do, then that says don't communicate down the serial link, which is actually the path we do want to communicate on, because I want to talk to router 3 at the other end over there. I want to talk to this guy over here. So don't put the interface on passive that you want, that has a router at the other end that you actually want to communicate to. So on router 2, what I want to do there, I want to type in class for that password. I want to put passive on actually both these interfaces, even though I'm not advertising that one. I still want to put passive on that. So configure terminal router RIP, and I'm going to go passive interface gigabit 00 and 01 as well, because I never want to send RIP updates to my ISP. There has been networks pulled down, and big networks. I think Telstra was pulled down a few years ago by someone whose edge router sent a routing update into Telstra, and it updated everything. I think it's partly Telstra's fault, but anyway. So let's go on to router 3 as well. Enable class conft router RIP router IP, and passive gigabit 00. So let's just see what's actually happened out of that. We'll go back into simulation mode and we'll auto capture. There's RIP going out of router 3 now, and it's went a bit quick, didn't it? Let's just work our way through it. CDP running. So router 2 is just sent down to these two routers. It did not send into 192.168.111. And router 1 having a bit of a dig as well. So good. We've actually got not a bad little network there. So let's have a look at our running config. So show run. We've got the basic configs that we've done before: service password, host name, enable secret, no IP domain lookup. There's our interfaces all built, all the stuff we've done that we wanted to put in. Our serials are up. We've got our clock rate in there. One thing I don't actually have here is descriptions of our interfaces. Not a bad thing to put in. Fairly simple. Here we've got router RIP, and we've got passive interface gigabit 00, and the networks that are actually connected to this router 1. No other networks. If we put another network command in there for 172.20, it just won't advertise, it just won't send it out. Further down, standard stuff, we've got our banner passwords on our console and VTY. I haven't turned off my auxiliaries, which you should do, but all well and good. Other commands I've done, so show IP route, and that's my routing table. You can see I've built new features into my routing table which have been added by the protocol. It's added via RIP, and there's those 3 networks. So everything at the moment is fully converged, which means everything is advertised and is correct on my network. We've looked at load balancing because we've got 2 paths here. We pulled out a link so that there was only one path, and it all worked, and it showed 2 hops to get to this network down here. We didn't actually see the bit where it took off the second load balance path, but I'll leave that for you to do. We've also got in here our passive interface, which says do not send routing updates down to my LAN network. I don't want that. people down there don't need to know what my router is actually doing, and from a security perspective it's a good thing, because you don't want to get your packets captured by Wireshark or anything like that. And look at RIP running through your network. Now, to finish off RIP version 1, there's other stuff we can do, but we won't at the moment. We'll leave it for version 2. This network is fairly clunky. I mean, it's working quite happily there. It'll work quite beautifully once it's up and running. Everything is class full. Generally, we will not run class full networks. You can, but generally you won't. Most stuff we actually want to learn is classless. And because we are using version 1, it's only sending the actual network numbers. So when they get to the other end, this router assumes that it's a classful network 192.168.10 that's been advertised. 172.20 down this side is being advertised by 3 to router 1 and router 2. So it assumes that everything is classful. And that's okay, but we actually want to get it running a bit better. The other thing I haven't added is the internet, and I'll just add that actually just right at the end. I'll put it into version 2 as well. So to get to the internet for everyone, we can put static routes on each router, so gateways of last resort, but there's actually a better way of doing it. So let's go into our conft. We'll put in a static route, IP route, and this is our quad 0 one. Gateway of last resort. It says in our routing table, if I do not have an exit interface, or I do not have a what's the word I'm looking for? I've lost it. Sorry. If I do not have a match to something that lives out there, maybe it's a 152.10.5.1 IP address that we want to get access to, that doesn't exist on this network, then send it out to this path. So this is our gateway of last resort, and we're going to send it out to the next hop address, which is out here somewhere. So let's put 2 in there. Now I'm assuming that this is a switch network, so I'm putting in the next hop address, not the exit interface. So this route is fine at the moment. So if we show IP route, we've got our gateway of last resort up there. It's a static. There's its administrative distance of 1 because I put in the next hop address. If I'd put in the gigabit 01 or whatever it is up there, it would not show that. Now router 1 would like to get a gateway of last resort as well. So I've showed IP route there. There's no gateway of last resort set there. Router 3 would like to get it. There's only one gateway. We can put in a static route on router 1 and a static route on router 3, but that's super clunky. Let's just go on to router 2 and let RIP do the work for us. So conft router RIP, and spelt it wrong, and spelt it wrong again. Goodness me. So default information originate is actually what we want to plug into RIP. So default dash information says grab my default route or my gateway of last resort that I have here. That quad 01 is a unique route, and I'll just hit enter there. So take that route, or that one, sorry, and say to these geezers down here, router 1 and router 3, that router 2, I know the way out of our network. It's through me. You've got to come through me to get out. So let's go back to router 1. So before it wasn't set. Show IP route. And now our gateway of last resort is set. And it's coming in via RIP. There it is there. It says to get to this network, which matches everything on the planet, RIP is sending it. That's our metric there. I mean, it's not our metric. That's our metric there, the 1, and the 120 is our administrative distance. So to get from here, if I want to ping 152.20.5.1, then a packet will arrive at this router. It will look at this routing table. It says I can't find a match anywhere up here. I will use this one as a last resort and send it out that path, which means send it up to RIP to router 2, and router 2 will then forward it on out to this guy up here. So all well and good. We have done that. So we should have a look at our last commands in there. So show run, and mess that up beautifully again. Obviously too late at night. So let's have a look at our router RIP. We've got passive interface running. We've got our directly connected networks, and now we've got default information originate, and that's only put on the router that has this static route. So this whole network here, you only have one static route. This one is directly connected to your ISP, router 2, so I put a static route on this router. In this case I put a next hop address. And on this router only, I put default information originate, because this one is the one that we want to take this route, chuck it into RIP, and send that update down to these guys down here. Okay, so let's have a look at router 1, and we'll show our running config there, just to look at our router RIP, and that's done correctly as well. Again, the 3 networks that are actually attached to router 1 are put in there, and passive interface down to our local network down there. And it should be the same for router 3, so just to harp on it. Ooh, bad. So show running config rune, and let's have a look up here. So our 3 networks, our passive interface on the actual interface in RIP. That's good enough for RIP. And all good. Control Z that, show IP route, and there's RIP giving us our exit for our whole network. Done. So RIP interior routing protocol, fairly slow, fairly clunky. This is RIP for IPv4. It's all well and good, fine. It's working. Everything will work quite happily there. If you're going to use variable length subnet masks, this starts to get a bit messy. I will build a new network, and we'll go through RIP version 2 in the next one. So thank you for that. Goodbye.